So today I will try to solve the exam. Huh? And simply, as you can see, I projected the exam sheet to the slide, so I can solve it while you can read the question. So let's start with the first part, which is the multiple choice. The first one, simply the first one in dynamic braking. Do you remember the dynamic braking? The dynamic braking, I will disconnect the supply and I will connect a braking resistance. Yeah? Good. So simply if I need to plot the torque speed characteristic, if I was here, the voltage now is 0. So I will cross this point, correct? Now, according to the I brake, I will generate different braking current, let's say. Yeah? Now, simply, if the braking resistance is minimal, this means that the I brake will be the maximum. Yes? So, increasing the braking resistance will what? Will reduce the braking current, which means that I will limit the braking current. And if I'm limiting the braking current, this means that I'm limiting the braking torque. So this means that the answer will be C. Yep. Now the second part here, if I am in the regenerative braking, in the regenerative braking, the load is driving what? The machine. So if I'm increasing the load torque, I'm accelerating the drive. Yes? If I'm decreasing the load torque, I'm de-accelerating the drive. So simply this means that the first sentence is correct and the second one is correct. Yep. So the answer will be A. Now a motor drive, a passive load, is said to be steady-state stable. We know that this, we already decide, according to the exponent, sign must be negative, which means that the variation of the load torque must be greater than the variation of what? Of the machine torque. So this will be the B, correct?
السؤال تابع اللي قبله.
No, here motor driving.
طب مش لازم الموتور تورك أكبر من الوش عشان هاي differential.
Now do you remember the differential equation? J d omega by dt is equal to Te minus Tl. If I do a variation, this will be what? J d delta omega by delta T will equal delta Te minus delta Tl, yeah? Now, delta Te or delta T in general can be represented as partial T by partial omega delta omega, correct? Now, if I spread the variable, I will have the exponent here, yeah? And this exponent is what? Will be Te, delta Te minus delta Ti. So in order over partial omega. So in order to make the exponent negative, yeah, this means that this one must be greater than this one. Yeah? And we did drive the formula. Now a series DC motor is operated in the forward motoring. Put 2 lines under the forward motoring. Now I'm what? I'm going to the supply and exchange terminals. Now if I do so, the flux will reverse and also the armature current will reverse, so nothing will be done. The motor will continue to rotate in the same quadrant, which is the forward motoring. Yeah? So the answer will be A. 180 blah blah blah. Okay. The fairing angle at starting. At starting, my saloon, omega equal to what? 0. So the torque will equal to what? 20. So simply, if I know the torque and I can find KT, then I can find the current. Yes. Then VA will equal to what? Only RAIA, because EA is what?
0.
Is 0. So from there I can calculate the fairing angle. Simply the thing that I will do is what? I will say that VA is equal to V max over pi cosine alpha, which implies that alpha will be cosine the inverse of pi VA over 2 V max. If I do the math, everything I can do it. This one, I will multiply it by what? 30 over pi. Yeah? Now, the firing angle in degree when driving the rated torque. Now, simply this I can solve with no time, by the way. I can take this one as a clue of the rated condition. And if I do so, it will be a 24.6. So the answer will be what? No, there. Now for yeah. ايش انت؟ اه And how you did that? Okay. So let's pi multiply by 180 over 2 square root of 2. Yep. Multiply by 220 cosine inverse. Yeah? Yeah? You have the calculator? Calculate. I think you miss the square root of 2. Yeah? It's V max. And I'm having a calculator here. It is the pi multiple 180 divide by 2 divide square root of 2 divided by 220 cosine the inverse, which equal 24.66. Yeah. So you are forgetting what? Square root of 2. Yes. So maybe you read it as 25. Or maybe it's supposed to be this here. It's supposed to be. Well, whatever. So the answer is D. For 7. 7, let's say. I'm having gravitational load, which means that the torque is what? The torque is what? Constant. Yeah? But simply here I'm asking about the pore speed characteristic. So simply the torque is constant. If I multiply here by omega, I will multiply here by omega, so the pore will be proportional with omega. So the answer will be D. Yep. Yes. 250 DC series motor drive a load which is proportional to N square, where N is the motor speed in RPM. At certain speed, the motor draws 40 ampere. The total resistance is 0.6 ohm. The external resistance is connected series in order to get half of the speed. So simply this is very simple. I will say that. Now the torque in series machine is proportional with I square. And also it's given proportion to N square. Yeah? So in this case I will get I1 square over I2 square must equal I1 square over I2 square. Huh? So this will be that I1 over I2 must equal N1 over N2. And it's given that the N2 is 0.5. Yes? So this means that I2 will equal 0.5 I1, which is the 20 ampere. Yeah? So now I'm having the current. If I need to find the voltage, VA will equal to what? RA, IA plus EA. So I need to find this one, EA. Now the same thing, EA is equal to what? EA is proportional with IA omega. Yes? So I will say that 1, 1, 1, then EA 2 proportional with IA 2, omega 2. And if I do the ratio, then this will be A1 over A2 will equal IA1. I can sit here and 1. Yeah. Yes. Because at the end of the day, I will take the ratio over IA2 and 2. Now let's see. Everything here is known. Yes. I1 is known. I2 is known. N1 is known. N2 is known. So I can find E2 because I know E1 from the rated condition. Huh? Now, if I do the calculation, let's do the math. If I do the math, then E2 will equal 6.5. So now this one we plugged here, this one is 20, this one is R total, and this one is already given, huh? Yep, 250. So from here I will find what? R total, I will subtract from it what?
160.
Because I'm asking about what? The external resistance. If I do the math, the answer will be B. Yep. Now 9, I'm having drive. This is the machine torque, and this is the load torque. And this one allows for a bidirectional. And I need to find the steady state speed. Simply at steady state, TE is equal to TL at steady state. Yeah? So simply this means that if I do the math, this will be 50 will equal to 0.05, and so simply n will equal to what? 1000. 10. A DC series motor with R total 0.5 drive a certain load and generate which has a certain torque. And I need to find the Chuber duty cycle if the machine draws 40 ampere and runs at 3-4 rad per second. My saloon, how did you solve it? Or you just put anything? Who can solve this question?
بس كبر النهاية شوف.
Okay. Let's zoom it. Okay? Yeah. So simply you would say that I'm having the torque. I'm having the torque, which is 200. And I know for the series machine, the torque will equal certain constant K, IA squared. So from here I will find K, which will equal T over IA squared. If I do the math, 200 over 40 to the power 2, and this will equal 0.125. Yep. Good. Now, simply, I'm having the current, so VA will equal RA, IA. This I can find with no time, which is the 0.5, I think, 0.5 multiplied by 40, so this will be the 20. Then, plus, EA is what? EA. EA will equal K, IA, omega. Omega is given, IA is given, and K is calculated, so I can find this one. If I do the math, this will equal 190. Now the duty cycle D will equal 190 over, it was what, 200? 200, and this will equal 0.95. So the answer will be A. Now, a tuber controls a feed. When the duty cycle is equal to what? I'm getting what? The rate. Now I'm reducing the duty cycle to 0.9. I need to find the new speed, the no load speed, as a ratio or in period. So simply this also very simple. We say that omega is inversely proportional with the flux. Yes? Yeah? Omega naught. Yeah? So simply here we will say omega 1 over omega 2 will equal 1 over phi 1, 1 over phi 2. And phi actually is proportional with what? With IF, which will be proportional with BF, which will be proportional with what? With the D. Correct? So at the end of the day, omega 2 will equal D1 over D2 multiplied by omega 1 as per unit. It will be 1 over 0.9, and this will be 1.11. So the answer will be C. 12. Simply I'm having what? Separately excited, and I need to start the machine such that the current is never allowed to exceed the maximum 2 times the rate. So simply, if here I'm having 2 lines, one to represent the rated current, I rated, or I, the second one will be what? 2I. Yes? Yep. Yep. And simply I can calculate the current from where? From the rated condition. If I need to calculate I, this will equal 220 minus. Now K5 is given in volt RPM, so it will be 1000 multiplied by 0.09 over the resistance, which is the 2. If I do the math, this will be 220 minus 209 over 2, it will be 5.5, I think, yeah? 5.5 million, yeah? So this will be the 5.5 and this will be the 1.1, yeah? So the first thing I will find this one, the initial duty cycle. How to find it? I will find the voltage here, VA at 0.1, let's, yeah? Now VA at 0.1, the speed is equal to what? 0. So it will equal I2, so this will be 2 multiplied by 2 multiplied by 5.5, and this will be 22. Yeah? So the duty cycle here will equal what? 22 over 220, and this will be what? 0.1. Yeah? So simply this means that I will swing out this one, yeah? And I will swing out this one. Yeah? Now after that I need what? To see the step change. So the first thing here, let's assume this one. I need to calculate the duty, the speed here. Why? Because after switching, I will go to where? To this position. Huh? Straight line there will be. So I need only to calculate the duty cycle or the increase of the duty cycle here. So here I need to find what to calculate omega. Yeah? Why? Because I need omega here. So how to calculate omega in this point? Very simple. VA I know 220 will equal the current I know 5.2. The resistance is 2 plus K5 I know 0.209 multiplied by the omega. So from here I can find what? Omega. If I find omega now, which is, if I do the math, omega will equal 2. I'm giving n 52.63 because this will be in volt per RPM. So let's take n here. So n will equal 52.63 RPM. So now I need to calculate the step I need to change. Remember, it will be straight line, huh? Straight line, the same slope. So the variation will be the same. So I need to calculate the D at this line. Now, at this line, the speed n is given. So 5, 2, 6, 3. The current is given. So simply, VA will equal 22 plus 52.63 multiplied by the 0.209. If I calculate it, this will equal 33. Now, if I calculate the duty cycle, it will be 33 over 220, and this will equal 0.15. So the step change will be what?
24.
So the answer will be what? Good. So this is the first, let's say, part. Do you have any question regarding the first part? So let's take the second one. Question number 2. Simply here I'm having a separately excited DC motor which has certain parameter, and I'm having the total inertia and the total viscous friction, assuming that I'm driving a torque which is proportional with the speed. I need to find an expression for the motor speed as a function of the time. The machine was, I'm imposing to the machine a suddenly 200 volt. So the machine will start to rotate. I need to find an expression for the speed, then I need to find the steady speed, and I need to find, let's say, the time that I need to settle down or to reach 0.95 from the final value. So simply here, I'm assuming that I can neglect the electrical part. From where? I'm assuming that the inductance is very small so that I can neglect it, which means that in order of magnitude, in time scale, the electrical circuit is seen constant with respect to what? To the mechanical part. Yeah? The mechanical. So here I need to solve what? A first order differential equation. I need to solve what? First order differential equation. If I did not neglect this one, I need to solve what? Second order. The first one will come from where? From the electrical part, and the second one, the first differential equation will come from the electrical part, and the second equation will come from the mechanical part. So now this one is also very simple. I will say that VA will equal RA, IA plus EA, which is the K multiplied by K phi or K in general, multiplied by omega, correct? This is the first equation that I need to think about. Then J d omega by dt will equal TE minus TI, correct?
minus B. معطينا
Yeah, but simply here it will be B total multiplied by omega. So this will include the B omega. This one, by the way, this one has the load and the machine. Okay. J d omega by dt plus B omega will equal TE minus TL. This TL is what? B load omega. Yeah. Take this one here.
طب ده اللي حاجة زي هيك دكتور تطلع مع إجابات غير عن
Simply I'm giving you what? The total. From where you are getting this one alone. B is equal B motor plus B load. This is the equivalent viscous friction. J equal to what? J motor plus J load. Yep. Yep. Yeah. So this will be what? B multiplied by the omega. Yeah? Now we know that TE is equal to what? K multiplied by IA. So from the first equation I will calculate what? IA. Just then I will put it here. TE will be here. So I will have what? A first order differential equation, correct? Yeah. First order differential equation. If I need to do that, so simply I will say VA of S will equal RA of multiplied by IA of S plus K omega of S, and J S omega of S will equal T, which is the K, IA of S minus the B omega. Now from here, I can say IA of S will equal to what? VA of S minus K omega of S over RA. Just now, if I substitute, I will get omega over V will equal to K over K square plus RB plus Rj of S. And now this can be written as K over K square plus RB over 1 plus Rj over K square plus RBS. So this would be the time constant. Yep. And here V is given to be 20. So omega will equal 200 over S. If I engage the parameter, multiply by 0.488 over 1 plus 0.244 S. Now, if I need to find omega of t, this will be omega steady state 1 minus exponential minus t over tau, and this will be 97.6 1 minus exponential minus t over the tau, which is the 0.244. Good. So this will be the first one. The steady state speed, this one, so this will be the second one. The time required to reach 0.5 of the steady state speed, very simple. I will multiply this one by 0.95 and I will solve it. I will take the ln, and if I do so, it will be the time will equal, it will be 0.732. Do you have any question regarding this one? No? The third one, I'm having a simplified drive system given certain parameter, and I need to design a controller, speed controller, such that the closed loop is first order. So I must do zero pulse cancellation. Why? Because the motor is first order and the controller is the first order. So the closed loop must be what? A second order, unless I'm doing what? Zero pulse cancellation. The first one. So simply the first thing, I must cancel certain term here with this one. So I will write this one as a DC gain and time constant. So I will divide by what? By 4. So this will be 2 over 0.1 S plus 1. So now I will cancel this one by this one. So I will have 2 with no time. Did I need to solve anything to get this one? No. No. I don't need to think about anything. Only understanding that what? The closed loop system must be a first order system. So I must do the zero pulse cancellation. Okay. Now, if you notice here, I'm telling you that the time constant for the converter is negligible, which means that the converter is only specified by a certain gain. If I need to calculate it, this is a 3-phase full converter, it will be 1.35 V line to line over V what? Yeah, which we call it what? VC. So if I do the math, this will equal to what? 4.5. So this is also 4.5. Did I need to solve anything? No. Now the last thing, now I need to find the closed loop. Why? I need to specify the K, the gain for the controller, according to what? The closed loop time constant. So now the block diagram. So now the block diagram will be reduced to be what? Here I'm having certain gain K I need to specify, and I know tau 1, which is the 0.1s. And this one I know it, which is the 4.5. And this one already we have, which is the 2, correct? And this is a negative feedback. Yes? Now, if I calculate the closed loop system, it will be what? It will be 9K over 0.9 S plus 9K. Now, I need the closed loop time constant, so I will call it tau C, to equal to what? 0.02. So this must equal to what? 0.9 over 9K. So if I do the math, K will equal 0.55. Yep. Is it difficult? Huh? Is it difficult? Huh? Now the fourth one. Plot the block diagram in the S domain for the field control separately excited DC motor. No need to add any controller. Plot the block diagram of the machine alone. Now, if I'm discussing a field control, this means the armature is what? Fixed. So I don't need to do anything to control the armature. Now, do you remember in the field weakening? We said that to maximize the torque, the current must be maximum. Yes? Yes? So simply, this means that the torque is proportional with what? With IF, the flux, and IA. And this one is maximum. So, in the end of the day, this means that TE is proportional with IF. Yes? So, this means that TE will equal certain K multiplied by IF. Yeah? Now, I'm having the field circuit, which is VF will equal to what? RF, IF plus DIF by DT. In terms of Laplace, this means that I'm having the input, which is the armature, which is the field voltage. Then I'm having 1 over RF plus LFS. And the output is what? Is IF, huh? If I need to take this one in Laplace, VF of S is equal R plus LFS all multiplied by IF. Solve with respect to IF, you will get this one. After that, I need to represent the machine, you have two parts, electrical part and mechanical part. Yeah? The first one here specifies the electrical part. If I multiply IF by K, I will get the torque. Yes?
Yes.
Which is the TE. Now the mechanical part, we know that swing equation, which is the J d omega by dt equal TE minus TL. In terms of Laplace, this will equal to what?
GS.
If I'm adding here plus B omega, yeah, it will be what? JS plus B omega must equal TE minus TL. So now I will subtract from this one what? TL. Then I will multiply by 1 over JS plus B, and I will get what? Omega. And that's what I need. Yes? Difficult? Yep. No, it's not. Oh. The last one. I need to plot the hysteresis current control. Block diagram needed to generate the gate pulses for the two quadrant chopper fed DC drive and generate the gate pulses in between the two lines. Simply this one is not. I will replot it here. Because notice this one was handwritten. Yeah? So at first, let's plot the circuit. Plotting the circuit, this means that the first switch, the second switch, each switch has anti-parallel there with it. So here I'm having the gate pulse, let's say Q1, here I'm having Q2, and here I'm having the machine. So I will measure the current, let's say. Then I will compare it with IA reference. After that, I'm using a band control. And the band control will generate what? Q1. The lot of that will generate what? Q2 according to Q1 will equal to 1. If IA is this than or equal IA reference minus delta I, the band that I need, and 0 if IA is greater than or equal IA reference plus delta IA. Yep. Yep. And I think I gave you a certain band here, one here, and one here. And after that, this is the reference current. And I'm telling you that this is your current. Yeah, something like that. And I need only to put let's say in between this point to this point, correct? Let's say roughly. Yeah. Now I will put Q1 and Q2 will be the inverter. Now from this point and before, I'm having the logic 1. It will maintain until this point. Yes? After that, I'm hitting what? The upper bound. I must turn off the switch. Then the switch will be on if I hit the lower bound, not the intersection between the response and the reference. Correct? Only I'm switching what? On the boundary. That's why we call it bang control or on-off control. On the boundary, the action will take in, and I will preserve the action until the second band will be hit. Yep. So after that, I will on it. Here I will off it. On it, I will off it. Yep. So this will be the gate pulse. Yes. So this is the exam. Now we solved the exam. We discussed the exam, and it's taking less than 30 minutes. Yeah. Really, I solved the exam. Yeah. Yeah. Okay. So now, your feedback regarding the exam. Do you have any feedback regarding the exam? وائل جهاد علي حمزة. No feedback. Maram, the exam was cheesecake. No. Sponge cake.
لا مش هين.
مرام حمزة هذا من حمزة وراك. مرام ايش؟ 11.
طيب
وصلنا.
كيف
Reading is fundamental. مروان ادرس. من درس نجح.
درست
أحمد. So what's the problem? أحمد أبو صالح. احكي لي يا سليمان شو مشكلة؟
مشكلتي وحدة بس بدي اتخرج مش عارف درست مش
خلي آخر همك إنك تنجح بالمادة.
ليه بدي اطلع
أحمد فحماوي. مهند. Let's discuss the exam. Later on we'll discuss your situation. مهند. ميسرون. عمر. محمد. وعلاء الدين. أسامة محمد زيد نوال محمد زيد أنت نوال أنت؟ أيوة لا أنت الثاني صح؟ أحسن ولا أسوأ؟
نفسها.
إيه أسامة الفقهاء أسامة اليزيد عمر عبد محمد صالح بهاء كرم عبد الله زياد مين كرم موجود أمانة الله موجود طيب اسمع شو كنت تحكي قبل شوي؟
كنت سامع ديسكشن عن الالتزام
أعطيك علامتك أونلاين
لا شفت
خلاص ما بدك شيء يعني أعمل لك بوست خلاص عبد الله زياد إبراهيم غادة إبراهيم شايف أجى علي بيقول لي زعلان بيقول لي مصلح لي ومش حاط له علامة by the way I have bad habit I'm not good in math بخطأ بالجمع شو عندك خطأ بالجمع؟
لا مش خطر مقبول.
خلي مع بالك so the first thing you should do is what? To check the summation huh? After that to check everything is checked yes or no yeah? إذا في شيء تحكي لي ما في شيء خذها معك محمد هاشم محمد أمين أبو طبيخ معتصم عبد الله الخصامي أحمد منصور أحمد يونس حدا ما طلع اسمه عبد الله أوكي سليمان سبحان الله محمد جروان مش موجود نمرس مش موجود نعم آخر واحد صح كل أخذ علامته بالقاعدة أوكي now the first thing I need to discuss with you in general the exam was difficult or average above the average slightly above the average by epsilon where epsilon go to 0 take the limit
هو ابسط الابروتش
it's epsilon huh? plus epsilon right. So let's say that it's within the average difficult within the average okay so where's the problem if the exam within the average so you must score within the average so at least you must score within the average so what's the problem شو مشكلة؟ احكي لي انه اسئلتك مش منطقية يا اخي.
لا منطقية.
طيب.
بحضر المحاضرة.
طيب so what's the problem؟
مش عارف. عشان هيك بسأل. عن جد مش عارف. في الأفرج مش ناجح. في طلاب عمادة كثير واضح. يعني إلا ما في ايرور تصمم.
اوكي.
على الأغلب
نعم.
بس إيش نعمل يعني؟
Now in general, even if you think that the question is very simple to solve it. While solving, you'll discover that it's not that simple that you think. Sometimes solving the problem depends on your understanding. Yes? So simply practice is fundamental. You should solve. Good. The first thing. The second thing, don't memorize. So you say that this questions, I saw it in the first exam before 3 years. Yeah? Solve it. Because I will put the same answer. Yeah? There will be the same answer. So you will say that this one is that one. Huh? So in general, try to solve the problem, don't memorize. After that, do your best. You still have 20 points. Yeah, the 20 points is for what? For the quizzes. Yep, for the quizzes. Good. So we agreed that the exam was not that tough. Later on, I will see what we can do in order to enhance that. Good. Do you have any question before continuing with the lecture?
في ناس شو اسمه ايش؟ الجمع في عندي واحدة
الجمع؟ شو الجمع؟ شو كده؟ احكي لي. ستة. طيب شو مشكلة؟ من جد والله؟ 1 2 3 4 5 6 كيف عدد بصراحة؟
ايوه
شو هي؟
صح
هاي واحد هاي اثنين هاي ثلاثة ها؟ هاي أربعة هاي 5 وهاي 6 شو يعني؟ ماشي بس
لا وفي كم كتاب ورا
ايش
خلاص في هي الدائرة لا خليناها
خلي
طلعت ننهي تمام هي بتطلع هيك مش عارف انا طلعت معي هيك كثير ناس طلعت 25 بس هي انت طلعت 24 بس بتطلع قريب كثير طلعت
ذا ماجيك
25 زي هيك
اسمه ماجيك
طيب دكتور خربط يعني واحد ظنن اللي يحط زي هيك
اللي عنده بده يراجع ورقته يعطيني اياها ما بده يراجع ورقته خليها تمام. Okay. So let's continue with chapter 5. Well, last time I promised you to solve some questions, but yeah, in order. Actually, I'm trying to break. Otherwise, I will enter to dynamic modeling, and in the dynamic modeling, I need to simplify things for you. موجودات على الديسك فبحاول افتحه. Okay. So next page. So let's try to solve some question regarding the constant V over F. By the way, I posted to the e-learning video to discuss how to design the BI gains for constant V over F graph system. Then I posted, it's all videos actually. Simply discuss the same thing. So let's take the following example. Now we're having a Y connected three-phase induction machine has the following parameter 400 volt 50 hertz 1370 RPM RS equal 2 ohm RR dash equal 3 ohm and we assume that XS is equal to XR dash which will equal 3.5. now this motor is connected, the motor is connected to a voltage source inverter. Or for short VSI, that operated at constant V over F. The inverter allows frequency variation from 10 to 50. And we need to obtain a plot between the maximum torque and the frequency. So the first thing here we need to do obtain a plot between the maximum torque Tmax and the frequency. After that, we'll discuss that. Okay, so simply here, I'm not telling you that you can neglect the drop voltage across the stator circuit or RS, including, let's say here, I will put here, do not ignore RS and XS. Yeah. So how I can solve this one? Now, because I need to plot Tmax with the frequency, the first thing I must write the relation of Tmax. Yeah. So Tmax you still remember, it will equal 3 over 2. Now I will put here K omega Sm, and this one will be the rated value because I'm including K. Then here I will say K square V square, and this will be rated value because already I modified the voltage according to a K. Yeah? Over Rs plus the square root of Rs plus K square, and here I will put XL XS plus XR dash square, and those will be what? The rated value. Correct? Yep. Yeah. Now omega Sm will equal to what? Equal to what? Now, this machine, is it how the poles, the number of the poles here equal to what? 2, 4, 3, 1.5, 4. Why 4?
Rated speed.
Yeah, it's 1370. So the synchronous speed should be what? The closest synchronous speed to this one, which is 1500. So this will be 4 poles. Yeah? So from here, I can say that NS is equal 1500, and this means that it's 50 hertz. Huh? So this means that the P is equal to what? 4. Good. So omega S I'm equal to what? We know that omega S is equal to pi F. S. Yeah? Yep. So omega Sm is equal to what? 2 over P omega S. So this will be pi F. Which is 50 multiplied by the pi. Correct? And this one is what? This voltage here. What? This one. Line to line, phase, RMS, maximum. Line to line RMS value, the standard thing. Huh? For three-phase system, the nameplate is given such that it show what? Line to line RMS value. So what's the relation between the line to line RMS value and the phase? Over square root of 3. Square it will be 3. So 3 will be 3, according to the Bachmann theory. Yep. So according to the Bachmann theory. So I can say this one neglected, and here I will put what? Phase. Sorry, line. Yeah? Correct? Yeah? So I will use this one directly.
هي اصلا فيها phase.
Yeah, it's phase. So it will be line to line over square root of 3. Square it. So I will get the 3. And I'm having 3. So the 3 will eat the 3. Yeah? Yep. So now T max, this will equal to, if I'm calculating, I will get the 509.296 over 2 over k plus the square root of 2 over k squared plus 49. So what I did, I divided by k in order to remove it. Then this one is 3.5 plus 3.57 squared 49. Yes? And RS is 2, so 2 over k squared, because here I'm having k squared. Yes? And the k here will eat this one k, and I will get 2 over k. Good? Now, I'm having a relation between k and what? And T max. So I can build the table and say here k, and here I can put what? The frequency, and here I can put the T max. And I will start with, let's say, from the highest k, which is the 1, when the frequency equal to what? 50. So if I do the math here, the only unknown is what?
K.
So if I specify k, I can calculate T max. Huh? So if I do the math here, I will calculate the max, which is T max for 54.88 Newton meter. This one.
طب ليه جبر الاثنين والكي هذه مش RS مش هذه؟
This one not square.
بس لا تحكيها ليش الاثنين مع
This one, sorry, this one are square. Then I will do step change by 0.1. If k is equal to 0.9, the frequency equal to what? 0.9 multiplied by 50, 45. So if I put k here, if I calculate, this will equal 53.24. 0.8, 0.7, 0.6, 0.5, and I will stop where? 0.4. Where I will stop? Yeah. So k equal to what? K minimum is equal to what? Point 1. Huh? So I'll stop at point 1. Huh? So let's take only 3 values. 1, 2, 3, 4, 5, 6. So 0.8, which is the 40, 35. Then I'm having the 30. Then I'm having the 25. And because I'm too old, I will stop at 0.4. Okay? Calculating at 0.8, this will be 51.24. At 0.7, this will equal 48.89. At 0.6, this will equal 45.89. 94, at 0.5, 42.22, and finally here 37.44. So if I need to plot it, what I will do? I will mark the points, correct? So I will say that this is the frequency in hertz and this is the torque. And I will specify at 0.4, for example, the value is here. At 0.4, 0.5, 6, 7, 8, 9, okay. So let's assume that I'm having different points, one here, one here, one here, one here, and here. And here it will be something like this. Yep. Yep. Now, what about if I'm telling you that assume RS and XS is negligible? Who can plot the torque as a function of speed?
لأن K و X R الجذر.
So let's write it here. Now, I need to do the same thing. I need to plot the same thing. Huh? I need to plot T max versus the frequency. If RS and XS can be ignored. How I can do that?
يكون لينير.
Linear.
2 over K.
2 over K. Linear. So linear can be anything. Linear with what slope? So simply this is the frequency, this is the T, this is the F minimum, this is the F max. It will be what? Constant. Yeah, T max will equal what? Constant, which is T max what? Great. Yes? Yes? Yeah, correct? From where?
K بالجذر وكيف
So simply, we discussed that in the electric. If RS and XS is negligible, then the maximum torque will be what? Constant. Huh? Yes or no? Yeah, from here, man. T max will equal to what? 3, 2K, omega Sm, K square, V square. Now this one will be what? K, X, R. Yes? K will eat this one will eat this one. And in the end of the day, those are constant. At the rated value. Yes? Yes? Why? Because this one is actually the rated mechanical speed. This one is the rated voltage. This one is the inductance calculated or the reactance calculated at the rated condition or at frequency 50 Hz. Yes? So this means that if I'm neglecting RS and XS, it will be what? Constant. Yep. Good. Now for the same example, let's assume that I need to find the speed for frequency of 30 Hz and 80% of the full load. So let's assume that this will be 3. Find the speed for a frequency Hz and 80% of the full load. Sure. How I can solve it? Who has another clue to solve it?
نفس ما حلينا الأول بس بحسب عند 80% من التي ماكس وعندي بدل 50 هرتز 30 هرتز.
Good. Now this is the full load, huh? And let's assume this is torque with full load in the regenerative brake. You know that this one is what for generator and this one for the motor action. From here to here is almost linear. Yeah? Yeah? If I change the frequency, what I will do, I will shift this line. Yeah? Yeah? The last one is not the same slope. Yeah? So the slope are the same. If the slope are the same, then the drop speed are the same. Correct? Yes? Yes or no? Okay. So the slip speed and slip at full load equal to what? Do you remember the speed was what? 1370. So this will be an S minus an R, so this will be what? 130 RPM, correct? Yes? Yep. Good? Correct? Now, the drop in speed, if I'm having the full load, it will equal to what? 130. If I'm having 80%, I will get what? The torque is proportional with what? Omega slip. Correct? Yeah? So similarly, this means that TF, full load, is proportional with N slip full load. So T1 is proportional with what? N slip 1. So can I find N slip 1? Yes, it will equal to what? Correct? So this will equal to what? 0.8 multiplied by 130. Correct? Yeah? So now, at 80% load, the unslip now will equal to what? 104. Good? Good. So, I need to find the speed. If I'm having the slip speed, how I can find the speed? From the sequence. From the sequence speed. Can I calculate the sequence speed? Yes. 30 Hertz. Yeah? So I can calculate on the sequence speed. The sequence speed equal to what? Yeah. علامة. أعطيني عندنا. So Suleiman, he answered 2 questions, so you get 1 point. ذكرني بيه بنسى. I plus 1. So simply, I can calculate at 30 Hertz, NS is equal 120F over P, which will equal 120 multiplied by 30 over 4. If I do the math, this will equal 796 RPM. Yeah? Sorry, this will be 900. Sorry. Right. So this will be the 900. So now, who can give me the NR equal to what now? Yes. There's no 4. 104, and this will be the 796. 796. Good. Now, 3. This question with 1 point. The frequency for speed of 1000 RPM and full load torque. Find the frequency for speed of 1000 RPM, and the other, by the way, you are invited. Full load torque.
دكتور مش نفس اللي عملناه فوق بس بالعكس.
يعني
مثلا بدي احط انه 100 بدها تساوي اكس هذا على 4 يعني احولها معادله وبعدين بس فكره انه قاد 80% من اللود بدي اخليها 1.
so
هسا نفس
تصير على السينكرونس سبيد.
so
هاي زيرو.
so the drop speed are the same. Why? Because those are parallel lines, the same drop, the same drop. So I'm having the drop. If I add it to this one, I will get the synchronous. Then I will plug it and play here, sir. شو اسمه؟ محمد هاشمي get one. Plus me. Yeah. So if I do the math, so I will say that now asynchronous will equal 1000 plus 130. Why? Because those are parallel lines, the same drop at full load. And this will be the 1130. Then I will say that NS will equal 120F over P. So the F will equal 2 NSP over 120. If I do the math, this will equal 37.67 hertz. Yep. Good. Now, what about if I am in the regenerative braking? In the regenerative braking. Just in the regenerative braking, the speed for frequency 30 hertz and 80%.
دكتور عندي سؤال.
Yeah.
عندي سؤال.
أتفضل.
هسا سؤال 4. هسا نزلت السرعة ل 1000 RPM صح؟ يعني
no, the machine now, I need to find the frequency at which the machine will rotate at 1000 RPM while driving the rated load.
تمام. هسا كم السرعة فوق؟
Wait.
نمبر 3.
That was at 30 hertz. That was at 30 hertz.
أي تمام. يعني هي زادت، يعني هسا زادت الفريكوانسي بمقدار 7. 7.67. يعني نقصت السرعة بمقدار معين.
So
يعني فوق كانت 30 صح؟
yeah.
تحت 37.67.
Yeah.
هسا زادت 7 الفريكوانسي.
7.6 something.
تمام. هسا زيادة الفريكوانسي شو كان سببها؟
I'm using inverter. I'm using V over F. Yeah? Which means that I'm now controlling the frequency and what? The voltage.
تمام.
Good? So simply, if I'm changing the frequency, those lines will change. Correct? Correct? While the lines are almost parallel. By the way, this is approximation. Why? It's valid approximation because I'm only discussing what? The linear region. And not only all the linear region, the restricted linear region between the full load in the motor side and the regenerative braking side. Correct? So those are actually a parallel line, almost a parallel line. Correct? Now here, I'm not telling you that I'm changing this and this. I'm telling you that now the frequency is 30 and the machine is driving what? Certain load. Yeah? Give me the speed, give me the frequency. those are controlled by what? By the inverter. Yeah. This question only to highlight that those are parallel lines. So I can rely on this relation in order to what? To calculate. Otherwise, it will be tough to calculate it. Yeah? For example, in the 80%, I know here the torque is proportional with NS, the slip, and slip, correct? Omega slip. This actually we already found when we discussed the flux control or V over F control. We drive it mathematically. Yeah, in the end of the day, we get what? TE is proportional with omega slip, correct? So if it's proportional, then from the knowledge of the full load, the rated condition, I can calculate any point giving only what? Either the speed or the torque, correct? Yeah? So now, this one's what? In the regenerative braking, I need to calculate the speed for frequency 30. The speed for F equal to 30 Hertz while I'm driving TL is equal 0.5, 0.8. CF load.
1030
انا اسمي واربعه
تطلع 1030
نفس
إيه. تطلع
تطلع نفس الان
نو
اعلى بتزيد 1030
اعلى من ان اس بلس بدل
Plus.
ماينس
Plus. Why? Because I'm in the regenerative braking, correct?
90 بلس ال 100
تطلع بلس
1030
So it will be 900 plus 104. So this will be 1.004 RPM. So the blood is lost between the tribes. لكلكم جاوبتوا مش راح اقدر اعطيكم. No. Okay. Good.
كيف رسمة الاندكشن موتور في الفور مودز اوبريشن؟
Now, Ali is asking about, we did plot the torque speed characteristic in the fourth quadrant for the separately excited DC machine. What about if we do that for what? For the induction machine, yeah? So let's try to do that. Now, in general, I will upload it here. Okay. So this will be the speed. This will be the torque. So let's assume that this is the NS. And here I'm having a slip that's changed the color of the slip. So for here, the slip here is what? Is 0 and here is 1, yeah? Then I will plot the first one. Let's take slowly slow. Yeah? Now, if the load caused the machine to rotate in higher speed than the no load speed, I will enter to what? To the regenerative braking in the same direction of rotation. So I will enter to the regenerative braking here, correct? Yes? Yep. Good. Now what about if I continue plotting here? Here is what?
نيجاتيف سبيد
speed like this jump.
Yeah, this is plugging. I'm doing what? Plugging.
اللي هي ريفرس
I'm trying to reverse the machine by what? By exchanging any two phases. You know that for the induction machine, exchange any two phases, then it will be what? Okay. Now, which is faster? The electrical system or the mechanical system? So if I exchange any two terminals, the flux will reverse. So the sequence speed will reverse, while the machine is still rotating at what? In the same direction. Yeah?
يس
Yes?
تو الليبريت
So now, S will equal to what? The slip will equal to what? If I'm allowing that what? I can do what? Twice the maximum speed. Which means that. Now here, at this point here, this is the NR, and this is the NS, correct? Here. this is the NR, and this is the NS, correct? Yeah? And the slip is equal to what? NS minus NR over NS. So here the slip is positive from 1 to what? To 0. And here negative from where?
-1.
From 0 to where?
From 0 to 1.
0 minus 1.
To minus 1, correct? To minus 1. What about the plugging? The plugging, if this one an R, this will be an S. Correct? Yeah. So here,
هيطلع more than 1 يعني.
2
2.
More than 1.
The maximum is 2. Yeah? So this is the 2. Huh? Now, this we call what? The plugging or the tail. It's like the tail. This is what? The motor action. This is what? The regenerative braking or the generator action. Now, I ask a question. What about if I was operating here? For any reason, I was here. Yeah? And I did exchange the tail nut. So, what I should do, if this one is the forward motoring, I must have another one, the reverse motoring, right? So, now you know that this is the, let's see, let's do this one here. If this one is the forward because the speed is positive, this will be the reverse. So simply this means that actually I'm having also another one here. Yes? Now here I need to use two axes for the slip. One when the slip this direction and the second one when the slip the opposite direction. Why? Because I will have tail. This one is also the tail. Yeah? Now here, in this case, this will be what? The 2. Correct? In this case, this will be what? The 0 and the 1. So now I will replot another axe, and I will use it as green axe. Correct? The green axe. Green axe. So for this case now, this will be the 0, this will be the 1, this will be the -1, and this will be the -2. Correct? The 2. Sorry. -2 multiplied by -1. Absolute value of the minus. So, thank you. So now, until here, I did not answer. Huh? How I can go from this point to this point? 1 point question.
بالبلجين
كيف يعني؟
يعني عن طريق البلجين كيف وصلنا لهي النقطة؟
لا, how I can go from the from point number 1 to point number 2.
بنزل تحت.
كاركترستيك مع انهم نفس السلاب. اطلع ما بعرفش كيف مشت.
ايه مش مشكلة. اكبس على يعني اي شيء بوينتر. بس حط البوينتر اي حاجة. ايه خربش مثلا.
ايش اكبس عليه عشان يرجع؟
بس حط نزل ايدك يعني نص معناه كده ترجع كده تكتب.
اوكي. كده كده من هون بمشي مع
لا خلاص.
دكتور حتكون تقطع الزيرو من الاستفادة.
روح روح. عادي خليك تكتب على ورق. هاي دولار هاي ورقة. خذها. شايف ماشي وين صار؟ ايش غير بوينت. No. Sam, can you do it? Yes, I can. Okay. Now, remember, the first thing that I will do is what? If I exchange the two lines, then the torque will reverse while the speed are the same. Yes? Yes. So simply this means that I will go from 1 to point A. Yeah? The speed are the same. The torque reverse direction. So I will do what? Deacceleration. Crossing the zero. Then accelerate in the opposite direction. Correct? Thank you. This is not okay.
لا
Good.
طب لو عملنا دايناميك بريكنج ولا ما؟
Now the dynamic braking for the induction machine slightly different from the DC machine. In the dynamic braking, what we will do? For the dynamic braking, I will disconnect the terminals of the stators. If I disconnect the terminal of the stator, the machine will be what? Free run. Yeah? But I need to break it. Then what I will do? Remember, what make the induction machine rotate? The alternating flux. So if I make stationary flux on the stator, then the rotor will have also stationary what? Flux. Then the north will catch the south, and the south will catch the north, and they stay together forever. They are stationary. Good. So how to generate stationary flux? By imposing a DC. But remember now, I'm having AC circuit here, so I will be what?
Small DC.
I will engage a small voltage such that a rated current will flow. Yeah? So simply here, so from where the DC, someone will say I'm having three-phase supply. So I will use what? I will use a rectifier. Let's say rectifier either three-phase or single-phase. Let's assume it's a single-phase for simplicity. It can be controlled or uncontrolled. If I do the math, if I'm good in calculating, I can calculate either the transformer here I need to engage. Let's engage a transformer. This transformer, it can be. Huh? This is a transformer. So after that, here I will use the uncontrolled rectifier. It can be controlled or uncontrolled. That assume that I'm living in the heaven. So I will use uncontrolled rectifier. Those will be connected to the terminal of the machine. Any two terminals. I don't need the three. Only two terminals are enough for me. This one is floating. Now the stator will generate, let's say, stationary. This is a north, that assume, and this is the south. Then after that, the rotor also will generate two holes, that assume, and this will be the south, this will be the north. The south will catch the north will catch the south, and they live happily ever after. So, yes, this is a dynamic braking. It's very, very fast to brake the machine. Good.
كيف بيمشي هالكيف؟
Now the way. Now let's assume that this is the torque speed characteristic. And I'm wasing here. Now if I disconnect the supply, simply this means that I break the alternating nature of the machine. And now the machine become what? DC. Correct? Become what? DC. Yep. So simply this means that the machine will start to stop. It's the load. It will behave like DC machine. It's not DC machine. It will stop directly actually. It will generate huge rotation. This curve is not valid anymore because this curve for certain V and the frequency. Now the frequency is 0, so I'm here. The frequency is 0. I'm here. So I think it will go like this. Actually, this will be very, very, very fast break. Okay. Good. احنا معنا كم ساعة؟ يعني هي 1:30. لقاءكم لا يمل. Okay. يعطيك العافية. So next time I will start with the dynamic modeling of the induction machine.